In ERRA, we published this paper, and the idea was to focus on net metering scheme and prosumers. So idea was basically taken from case study from Georgia. Basically, it was quite a hot topic, quite previous years ago, and it still maintains the quite a hot topic. And based on that, we wanted to make some research how things are done in other countries. And if this pattern which Georgia kind of gone through, is it kind of seen to other countries also? And basically, the main case study is Georgia, but we also took some European examples, which is Italian one, just to have a sense how it is done in EU. And also we took some energy community contracting party, which is Kosovo. And so Georgia and Kosovo is on the same boat. So it is quite interesting to see what similarities are there. And the paper not only discusses the scheme itself, but we also dive deep into the regulatory framework, how it started. So I don't know, from fourth package, and before the fourth package, we saw some recommendations from European Commission, and everything is discussed in our paper. Not only the Italian and Kosovo case is explained, but also we have some United States examples there, which is quite interesting. Okay, before we will start the framework about the net metering, so just to have a global context before the scheme itself. So this is IEA statistics, which shows the percentage growth over the years and also the future kind of forecast regarding the solar. And as you can see, this kind of exponential growth, not only for the wind, but for the solar, it's quite similar. You can see that next few years, we will have this big growth in solar. And when you have this big, okay. Okay, and when you have this big growth, you need to have the system in place ready for that, and also the regulatory framework. Just to touch about the EU, because our paper is basically concerned to EU and neighboring countries. Here is also same pattern. So solar is also exponential growth from 23 terawatt to 307, and wind is 104 to 485. And let's see the Georgian case, how they have this installed capacity. So as we can see from the 2017, as the scheme kick started, so there was kind of not big interest in the scheme because the installed capacities were kind of moderate. But as you can see, due to years past, some quite big growth we have seen in the installed capacities of the solar PV. Maybe that was because of the threshold increased from 100 kilowatt to 500 kilowatt, and also small enterprises saw quite big economic interest in this scheme. In Italy, for sure, the numbers will be different. For example, if Georgian system had, I don't know, maybe roughly 140 megawatt, for Italy, we have 334 megawatts in the start of the kind of statistics. And we saw quite a big drastic growth in the first years, but there was kind of then a flat growth, not quite a big one. But from the 2021, 2022, maybe this is the kind of effect of the crisis, also energy crisis. We saw quite a big growth in solar. So, but the pattern is also the same, that we are seeing the growth in the solar. There's a quite good statistics for Italy. As you can see on the left side, there are the number of installations, and in the red circle, there is a small PV rooftops, made mainly 3 kilowatt installed capacity from 3 to 6, from 6 to 10. So basically, we can assume that those numbers are under the scambio sul posto, which is the net meter in Italy. So, but for the energy, if you look at the right side, so it's quite drastic change, because as you have this kind of industrial PVs, they for sure generate more electricity. So for kilowatt hour, you have much more for industrial one. For Kosovo, as you are aware, system is quite small, and installed capacity will be small for sure. And this is also seen here, but the growth is seen here also. And also we will see how scheme worked and evolved in Kosovo. Okay, so this was kind of context how solar growth happened during the years. And these have its effects to the system. So basically, if in 1990s and early 2000s, you had the conventional units run by, I don't know, gas-fired power plants, coal-fired power plants, CCGTs. So basically, it ran this downfall model, which means that you generate electricity in bulk, kind of big power plants, and deliver it to the end consumer. But here on the right side, as you have this more solar PVs, the system becomes decentralized. You have these PV rooftops, so new kind of market participants, the prosumers appear, as we see on the fourth package. And these prosumers kind of gives us quite a challenge if you are the system operator, and you need the right scheme there to control that. And if you will define the prosumer as a kind of definition of how it is defined, if it's seen in directive that prosumer is an end user, and this is end user which generates electricity for its own consumption. So it's quite a kind of to a focus that it's for own consumption at a private site located within the defined boundaries. Okay, if the system is changed and we have a decentralized system and we have these prosumers in the system, so then we have such a thing that electricity will flow from the lower voltage to upper side. So for these units of bidirectional meters, which will kind of meter your flows from the down to up. And in this case, the new term appears, which is electricity withdrawn from the grid and electricity injected to the grid. So this is when injected is when the prosumer is pushing the electricity to the grid, and withdrawn as end user uses the electricity. So let's take the figure from the Georgian NRA, which clearly represents how the net metering is working. And basically, we have this, you can call it reversal meter or bidirectional meter. Same. So basically, here you have these injections and withdrawals with the withdrawal with the green color and injections with the blue color row. So basically, what is done under the net metering? Let's take 1 month. You can take 3 months. I don't know. Depends on the regulatory framework how we define it. So basically, under the 1 month, if you had the injections to, for example, 10 kilowatt hour and withdrawals 10 kilowatt hour, at the end of the month, you can say that, oh no, my consumption is 0, so I have not used the system. So basically, my bill is 0. So based on the net metering philosophy, we can say that the grid is fully used, but billed as if were not used at all. So basically, during the month, when you injected electricity, you use the DSO's grid. You use the DSO's feeders, substations. Basically, I don't know, you supplied electricity to your neighborhood maybe, and it's quite unfair to bill as it was not used. And based on all of that, we can assume the 4 main aspects under the net metering. First is that grid is used as a free storage. So basically, when you push the electricity into the grid, you are assuming that, for example, starting of the month, I injected electricity, and you assuming that I will store the electricity into the grid, and at the end of the month, I can use it, and it's kind of, it's quite legal. Second is that DSO does not recover the costs, because if you have the volumetric network tariff and you inject and withdraw, and your bill is 0, so you paid nothing. So basically, DSO cannot recover its costs. And when you do not recover your costs to DSO, so basically others should bear it. That's the third topic. And the last one, which is the most important one, which we will discuss next slides, is that time and system value do not matter in the net metering, because you do not follow the hourly prices and the time bands on the wholesale market. Also quite good paradox under the net metering. Let's make a bridge analogy. So basically, if you have a car and you passed from the left side 5 times and the right side from the 5 times, you can assume that you've passed 0 times on the bridge. So this is quite a paradox, which is not quite realistic. Okay, let's touch about the time problem regarding the net metering. So basically, which you have this on the graph here, is that basically electricity generating during the midday. You can consume electricity here in these hours, kind of in the morning, and you can cover your consumption. But during the midday, you have this over generation, and you push this electricity to the grid. And basically, what you are doing that this electricity is stored for you as a kind of free storage, and you can use it next kind of days or months. And basically, what happens on the wholesale market at this point of time? Basically, as the market is dependent on supply and demand, the prices of electricity increases at the peak when demand is at the peak. So basically, you have these high prices here. You have high prices maybe in the morning peak, but during the midday, you are pushing this electricity and netting the high price electricity to lower prices to electricity. And this is not quite fair. And all these things, if you kind of continue these kind of things and add a lot of PVs together, you will end up at the one thing, which is the curtailment rates. And this is not seen only in EU, but all the countries which kind of track the curtailment rates, and the solar penetration is quite high in the systems, you see that curtailment rates are really high. For example, for CAISO and ERCOT, which is the California and Texas, they have quite a big solar penetration. And when you increase the solar penetration, your curtailment rates are quite high. So for that, you need to make these solar flexible. Flexible in terms of they should follow the market signals. If they will follow the market signals, they will install the battery energy storages. They will store the electricity on the lower prices and sell it to the high prices. So that's the logic. If we will look at how prosumers use the grid, and just to have a vision regarding that, if you are an end consumer here, just consuming the electricity, your electron that comes to the socket, it goes through a lot of elements, starting from the generator. Then you have step-up transformer, I don't know, then bus bars, TSO grid, DSO grid, and it ends up to your kind of house. So it's quite a lot of companies infrastructure is used to come to you, this electron. But for solar PV, it's quite different. So those two are quite different because your electricity is generated, excess electricity, and maybe maximum supply to your neighborhood or quite near DSO grid. So it's not quite the same. And let's talk about this vicious cycle which we see regarding net metering. Is that, for example, if you have a consumer A, for example, with the same consumption as the prosumer, 600 kilowatt in the month, basically what you have that prosumer will net its position. It will say at the end of the month that my average bill is €0, and neighbor A will pay the cost which kind of prosumer do not pay it. And this is only true in the volumetric tariff expenditure. Because, for example, if I have a capacity charge here, I will charge this capacity to prosumer, and basically this kind of cost which he has to inject the electricity to the grid will be borne by the prosumer. So this is the vicious cycle which should be solved. And to solve this, EU Aki and Energy Community Aki gave us quite big texts and big directions regarding that. And we saw in the fourth energy package that, for example, in the directive, it is clearly mentioned that, for example, here we can say that, for example, the separate for example, electricity injected to the grid and withdrawn to the grid should be charged separately. For example, in the regulation, also we talk about the cost reflectivity. Also, in the Renewable Energy Directive, RED 2, it is also mentioned, but in the revised version, you will not see this because in RED 3, this is not in place there. But before the fourth package, we also had this Commission staff working document in 2015, which clearly mentioned this problem that after some time, this net metering has its boundaries, and we should switch from net metering to net billing. So that means that before the fourth package, there was quite big discussions regarding that. Basically, not only the European Commission, but we saw a lot of papers from the CER and Acer, which signaled us regarding the net metering limits. Okay, one thing is to touch about the regulatory framework and the kind of this support mechanism But another thing is the technical boundaries and the limits of this technology, which gives us. As you know, the conventional units, when generate electricity, they have this sine wave, which is quite a perfect form. Not perfect form, but quite a perfect form to compare it to the inverter-based generators. So basically, what you have, this sine wave is from the conventional unit, but for the solar PV, which is generating the direct current, and then this direct current is modulated with the pulses, and the transistor, for example, with the openings and closes, the bridges generate this AC, gives us this chainsaw sine wave. So basically, this chainsaw sine wave creates quite big problems in the grid. And we saw it, which is written in the Georgian NRA's annual report, that it creates some problems because DSO has quite big problems regarding the harmonics, flickers, and the phase imbalances because it increases it huge. So basically, you can have the overvoltage in distribution feeders, especially in the summer when it's quite hot and you have the midday the maximum output of the solar PV, and it's quite challenging. And yeah, also we have really quite big problem regarding the short circuit current because for the protection systems you need to have the normal short circuit current to detect the faults. So for the solar PVs, it's also quite a big problem. Now, just to focus on the country cases and finish and wrap it up. So basically, for Georgia, we saw that from 2016, there was a kickstart of this scheme. It was kind of moderate involvement in the scheme, but in 2019, when the threshold was increased, quite big increase there was, and because especially from small enterprises, they saw quite good economics there because they could easily net their position, and it was kind of virtual netting. Basically, you can have a generator in the west side of the country, and you can net it to the if you had a load center to the east side. So it was quite easy for them. But at 21 and 24, there was quite network problems and stress which appeared, and you saw that NRA got some threshold and caps on the DSO grids. So basically, after a certain threshold, solar PVs cannot be integrated to the grid. And after 21, due to the fourth package and due to the energy community recommendations, so basically, scheme was changed from net metering to net billing with one exception, which is not kind of quite not U model, but injected electricity was billed as a universal service supplier price, which is quite low, and you can assume that, and you can consider that in the future it should be changed with a wholesale kind of competitive price, which is not in place in Georgia. For Italy, we have quite early developments of the scheme because it's quite clear it's European Union and it started quite early. This Cambio Supposto, which is net metering, started from 2005. It had quite big growth, as we've seen on the GSC data. The number of PVs integrated are quite big, and we saw this mass adoption in 2011 and then 2020. And the volumes increased quite big. And at 2024, there were tensions kind of because fourth package appeared and the system should be changed. And at the 24, system is phased out. But with the PVs, which still have this net metering scheme, it is same also in Georgia. To have their money kind of pay back, the contracts are in place, but after that, new net metering contracts will not be signed. Same pattern is in Kosovo, but it started a little bit late, so in 2018. And we have the same situation here, that at the beginning there was kind of small growth. In the 2021, there is a mass adoption, but due to the falling price of the PV equipments, this was also quite a triggering point for the Kosovo. And at the 2023, we saw these tensions also, which is the same as in Georgia. And also fourth package played the role. And at the 2024-2025, regulator reviewed this scheme and are working on the phasing out net metering and put in place net billing. That's it. I try to be quite short and not to overwhelm you with all the details, which is written in net metering paper. But if you have some questions, I think you will find everything there. But I'm also here to answer your questions.